In section 2.3, we're going to be talking about biconditionals and definitions. Biconditional is a statement using if and only if. To be biconditional, both the conditional statement and its converse must be true. So if we're giving the conditional, and remember the conditional statement is the original. So if our original conditional statement is if P, then Q. P stands for our hypothesis. Q stands for our conclusion. So if we read this statement, and the statement is read and it turns out to be true, once you read it, then we got to do the converse. Well, the converse, that's known as our switch. So once we do the converse, which is to switch the hypothesis for conclusion and then the conclusion for hypothesis, okay, if we read this statement and this statement turns out to be true, then what you end up with is called a biconditional. So the biconditional can be written as P if and only if Q, or you can write it as Q if and only if P. You can write it both ways because once both are true, they're kind of switchable. Okay, that's why it's called biconditional. So the symbol for this is P. Then you have an arrow, but it's going to point both ways. P, two arrows with a Q. So P if and only if Q. So that would be the symbol. Now for the conditional, that was P, an arrow pointing towards the right, followed by the Q. The converse was Q, followed by an arrow to the right, followed by P, because you switch the letters. So that's the symbolism for biconditional. You have two arrows. Okay. All right. We're going to go ahead and start with an example so you understand when to use these biconditionals. For problem 1, we're going to be writing a biconditional. What is the converse of the following true conditional? If the converse is also true, rewrite the statement as a biconditional. So here's our conditional statement. If the sum of the measures of two angles is 180, then the angles are supplementary. Well, the definition of supplementary is two angles that add up to 180. So this conditional, when you read the statement, is true. Now, what we're going to do is we're going to identify the hypothesis. The hypothesis is the sum of the measures of two angles is 180. Now we identify the conclusion. The conclusion is the two angles are supplementary. Now we're going to use these and do the converse. The converse is the switch. We're going to switch the hypothesis for conclusion, the conclusion for hypothesis. So we're going to take our hypothesis of our conditional and we're going to move it to the back as a conclusion. We're going to take our conclusion, move it to the front, and make that our hypothesis. Now we read the statement. If two angles are supplementary, then the sum of the measures of the two angles is 180. When you read the statement is also true. So this statement, the converse, is true. Now that you have two truths, both the conditional statement that you were given and the converse, now that makes it a biconditional. Therefore, we can go ahead and write it as the sum of the measures of two angles is 180 if and only if the two angles are supplementary. So by both the conditional and converse being true, this would be our new biconditional statement. Now let's go to problem number 2. For problem number 2, they want you to identify the conditionals in a biconditional. What are the two conditional statements that form this biconditional? A ray is an angle bisector if and only if it divides an angle into two congruent angles. So this is our biconditional. So we're working backwards. We have our biconditional. So now we just need to identify the hypothesis and conclusion. A ray is an angle bisector. That would be our hypothesis. It divides an angle into two congruent angles. That's our conclusion. Now, if we want our conditional, we're going to go ahead and take our hypothesis. A ray is an angle bisector, and put it here after the if. The conclusion then goes after the then, so we're going to take our biconditional, take that as our conclusion, put it after the then. The converse means we're going to switch. So we're going to take our statement if it divides an angle into two congruent angles, so we take our conclusion and put it first for the converse. Then we take our hypothesis and move it to the back. Then a ray is angle bisector. So now we have identified the hypothesis and conclusion, and we've come up with our two conditionals, which both are true. So we're working backwards from the biconditional. That's all you're doing for problem number 2. For problem number 3, we are writing a definition as a biconditional. Is the definition of quadrilateral reversible? If yes, write it as a true biconditional. The definition is the following. A quadrilateral is a polygon with 4 sides. This is a statement. We need to determine its hypothesis and conclusion. So I've done this for you. The hypothesis is a figure is a quadrilateral. So what I am doing is, based on this statement, I am identifying the quadrilateral to be my hypothesis. The conclusion would be it is a polygon with 4 sides. So I took my statement is a polygon with 4 sides, just wrote it so it makes enough sense that we can write our conditional statement. So now we're going to use this to help us write a conditional statement. So now once I identify hypothesis and conclusion from any definition or from anything given to us, now I'm going to write our conditional. So our conditional is if, and now we choose our hypothesis. We put it after the if. If a figure is a quadrilateral, then we follow our conclusion. It is a polygon with 4 sides. Okay, so we read it. This is a true statement. Now we go to the converse. The converse is the switch. So remember, the converse is always the switch. So that means we're going to now switch the hypothesis, and we're going to move that to the back. So we're going to take our hypothesis, put it now after the then, take our conclusion, put it in front of the if. So our statement reads, if it is a polygon with 4 sides, then a figure is quadrilateral. Again, this statement is true. Now we're going to write this as a biconditional because both of the conditional and converse are true. So we're going to go ahead and write our biconditional by putting the hypothesis first. A figure is a quadrilateral if and only if it is a polygon with 4 sides. So that's how you write a definition as a biconditional. We took our definition, broke it down to a hypothesis and conclusion. I wrote it so it makes kind of sense as a conditional statement. So sometimes you have to do that. You have to take our statement and make it work as a conditional. So once you have that, now we're going to switch both hypothesis and conclusion, which is our converse, reread it, find out if it's true. Since both statements are true, then we have a biconditional. And we write our biconditional by putting our hypothesis and then followed by if and only if, followed by the conclusion. Alright, so that was the last example. Go ahead and make a summary of the notes. What was biconditional? How do you know it's a biconditional? What are the things that you need to notice for it to be biconditional? Summarize that, and then tomorrow work on the problems in your work in your problems. And if you have any questions, you let me know. Okay. Till then, bye.